Hello everyone, welcome to the ITLS Academy. Today, the topic that we are going to discuss is a determination of magnesium, and the method that we are going to use is a calculation method. Yes, we are using a calculation method. But before starting the lecture, we have to know that why we determine this magnesium into a water, because again the sample is what? The sample is water. Okay, so the first thing is that the amount of this magnesium is decided the quality of the water. Decided the quality of the water. The first thing is that for the determination of the quality of the water, we have to determine the magnesium concentration into a water. Now, what is the impact of high concentration of magnesium into a human being? Suppose that if we consume a water and at that water the magnesium concentration is high. Now see what is the impact of what is the impact occur in our health. See, if the concentration of magnesium, if the concentration of magnesium is high or low. Suppose that is very high, is high or low, then it will lead to a total hardness into a water. It will lead to a total hardness into a water, especially a drinking water. So the concentration will not so high and will not so low. Okay, and it will create a problem like corrosion, scaling, and taste. Taste of the water will also change. Taste of the water will also change. Okay. Now, what is the impact of the human being of higher or lower um, concentration of this magnesium? Suppose that if the concentration of this magnesium are low, then it will lead to a cardiovascular disease, cardiovascular disease, and the concentration of magnesium are also important for a bone health. Okay, so that's why it is very important to determine that the water that we are drinking is what level of magnesium are there. Now see what is the level of the magnesium for a drinking water. So in a drinking water, the concentration of the magnesium should be at the range of at least 25 to 50 ppm. And human being require the the amount of this magnesium at least 450 to 500 milligram per day. This is a requirement for a human being. So this is the basic about the magnesium. Now let's start the lecture, that is the determination of the magnesium by a calculation method. Introduction. Magnesium occur commonly in a mineral magnetite and dolomite. Okay, so this magnesium are commonly occur in a mineral like your magnetite and dolomite, and this magnesiums are used in alloy, phytotechnics, flash photography, drying agent, refractories, fertilizers, pharmaceuticals, and food. Okay, so the most common type of the species which are of the magnesiums are Mg2 plus. It is what? It is the most common type of species. Common type of species of magnesium. The carbonate equilibrium reaction from a magnesium are more complicated than for a calcium, and condition for a direct precipitation of dolomite in natural water are not common. Important contributor to the hardness of a water is magnesium salt. Breakdown of this magnesium salt when it is heated. It is the most common cause of the hardness of the water, because the magnesium salt are heated and it is breakdown. And when it is breakdown, then the scales are formed during the boilers, and chemical softening, reverse osmosis, ion exchange, they are what? Chemical softening, reverse osmosis, and exchange. They will remove reduces they are reduces the concentration of the magnesium, and they are also associated with the hardness to a acceptable level. Magnesium is also an essential element in case of chlorophyll and for a red blood cell. Some salt of magnesium are toxic by ingestion or inhaling, and the concentration, if it is greater than 125 milligram per liter, then it will also have become a reason of catalytic and diuretic effect. Now the next is your principle of this experiment. Water sample contain calcium as a form of CaCO3 is estimated, and total hardness are the sum of the CaCO3 and MgCO3. Total hardness are what? Total hardness is equal to CaCO3 plus MgCO3, because it is also present into a water. CaCO3, calcium present into a CaCO3, and it will also contributed into a total hardness. Okay, now the next is your calculation, because we are discussing the calculation method. We are discussing the calculation method. So here we see the calculation part. Okay, so basically procedure is what? The titration method. Okay, we do a titration, and uh, like you in a titration you are using a dye. So here the Erichrome black tea are used as a indicator for determining of this, and the like pH of the water should be at the range of 10. Analysis for total hardness is carried out at pH 10 by using a Erichrome black tea as an indicator. Okay, simply what we do a titration. Okay, with the help of the titration we solve this equation. So total hardness, that is CaCO3 milligram per liter, is equal to 1000 in bracket V1 minus V2 divided by V3 multiplied by CF. Okay, where CF is equal to X1 divided by X2. Okay, now V1 is what? V1 is a volume in ml of a EDTA standard solution which is used in a titration for a sample. Okay, so basically V1 is a volume in ml of a EDTA standard solution, because we titrated with the help of EDTA. Suppose that this is your burette. In burette, EDTA will be filled. Okay. Now here is this is your sample into a, just let me again draw. Now this is your conical flask. Now into a conical flask, you will add it a water, or you can say that sample, plus this dye. That is your Erichrome black tea. Okay. Now, where endpoint is reaches, V1 is what? V1 is when the endpoint is reaches, you will stop the titration, and then you, with the help of this formula, that is your 1000 minus 1000 in bracket V1 minus V2 divided by V3 multiplied by CF. Okay, so basically the V1 is what? V1 is your volume in ml of a EDTA standard solution which is used in the titration for the sample, and V2 is the volume in ml of EDTA solution which is used in a titration for a blank, and V3 is the volume of the sample which is taken for the test. Now CF is what? CF is equal to x1 divided by x2, which means that it is a correction factor for a standardized ion of EDTA. X1 is the volume in ml of standard calcium solution taken for a standardization, and X2 is the volume of ml of EDTA solution which is used in a titration. By putting all the values into a formula, you will get the total hardness. See, not the amount of magnesium present into the sample, but you get a total hardness. Now the next is your calculate the calcium hardness as follow. Now again, uh, you have to analyze the calcium hardness. Calcium hardness are analyzed at the pH range of 12 to 14, and the indicator that we are going to use is Patton and Reader indicator. Again, you have to do what? You have to do a titration, same process. And when you the indicator that we use is a Patton and Reader indicator. Calcium hardness is equal to 1000 minus 1000 in bracket V1 minus V2 divided by V3 multiplied by CF. CF is what? CF is equal to x1 divided by x2, same. V1 is equal to volume in ml of EDTA standard solution which is used in a titration for the sample. V2 is equal to volume in ml of EDTA solution which is used in a titration for a blank. V3 is equal to volume in ml of the sample which is taken for the test. CF, that is x divided by x2. X1 is equal to volume in ml of standard calcium solution taken for a sterilization, and x2 is equal to volume of ml of EDTA solution which is used in a titration. Okay, and CF is your correction factor for sterilized ion of EDTA. This is how you calculate the calcium hardness. Then with the help of this, you will calculate the magnesium hardness, because the total hardness is equal to magnesium hardness plus calcium hardness. Okay. When you have a total hardness by using the first formula, then you also have a calcium hardness by using the second formula. Now you have to minus minus the total hardness and the calcium hardness, and you will get a magnesium hardness. Okay, so this is how you will calculate the magnesium hardness by our calculation method. So this is all about for today's experiment. I hope you will understand. But if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.